Hello everyone, I'm Sebastian Y and this is Managerial Economics. Over the next few videos, I'm going to introduce the field of game theory. This will set the stage for the rest of the course, where we are going to study oligopolies. For now, we're going to focus on one-shot games, which occur just one time, and later on we will talk about repeated games. This is meant to be a quick introduction to game theory, which will give us the tools to understand oligopoly. It's not meant to replace a full course on game theory. In this video, we are going to discuss what is a game. Game theory is the study of behavior in strategic situations. Broadly speaking, we define a game as a strategic situation. From a game theory perspective, a game has three components, and we need all three of them to fit into our definition of a game. The first component is players. We can't have a game without players. Players could be anyone from the participants in a chess match to firms competing for profit in the oil market. Broadly speaking, the players are the decision makers within the game. Players play the games by choosing from a set of available actions. A chess player's available actions are the various legal moves at any point during the game. If the players are firms, they might be choosing what prices to charge or how much quantity to produce. A game can have any number of players, from the simplest games with only 2 players, which we will focus on for now, up to an arbitrarily high number, n. In an n-player game, we will often refer to a generic player I, which is one of the n players. So I can be player 1, player 2, and so on, all the way up to player n. The simple games we talk about here are going to be 2-player games, so I can be either 1 or 2. Note we cannot have a game with just one player. Next, we need strategies. The actions a player can choose are components of their strategy. Some games are simple enough such that a strategy just consists of a single action. Other more complex games require a strategy to specify an action for all contingencies. For example, think about a chess player's strategy. The chess player playing black, who moves second, might have a different opening move depending on all the different actions the other player playing white could make. Note, however, that chess is so complex that it would be impossible to make a complete strategy for every contingency, since the number of possibilities explodes as the game progresses. Consider an example of a street with 2 gas stations. Each gas station owner's strategy about what price to charge will depend on the choice made by the other gas station owner. We will use set notation to describe the strategies available to a given player. We will use a big SI to denote the strategy set available to player I. Big SI contains all the possible strategies that player I can choose from. In chess, this is an unimaginably huge amount of possibilities. In the smaller games that we're going to look at later, this is a lot more manageable. From within that set of strategies, each player will select little si, which is one of the many possible strategies that are in big SI. Finally, we need to have payoffs. Payoffs are the utilities the players receive upon completion of the game. In many of the games we study in this class, our players are firms and so the payoffs are their profits, but they certainly don't have to be. The payoff to winning a chess game might be just the satisfaction of winning the game. As with any situation we've studied, players prefer to reach outcomes with higher payoffs, and will plan their strategies accordingly. We will write player I's payoff as UI of SI and S not I. The negative I simply means the strategies of all the other players who are not player I. Note that player I's utility function contains their own strategy, but also the strategies of everyone else. This is a key point in game theory that sets it apart from all of the other things we've studied so far. Each player understands that other players' actions affect them, and that their own actions affect the other players. All the games we are going to study here fall into the category of simultaneous games. Simultaneous games are ones where the players make decisions at the same time. This distinguishes them from sequential games where players move one at a time and observe the other player's action. An example of a simultaneous game would be rock, paper, scissors. An example of a sequential game would be chess or checkers. As I mentioned before, we are going to start out with one-shot games. In simultaneous one-shot games, each player makes a single decision without being able to observe what the other players are doing. The players only meet each other one time, and after the game is over, they never see each other again. Later on, we're going to look at what happens when we repeat these simultaneous games over and over. In the next video, we're going to apply all these concepts to two famous games in game theory and learn how to analyze them.